And press record. Well, good afternoon, everyone. Thank you for attending today's webinar, a conversation on NGCS GIS impacts on state and local governments. My name is Amy, and I am the Operations Manager at National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like to learn more about how to get involved with us, please visit our website, www.nisgic.org. Just some reminders for today. All attendees have been muted on entrance. There will be time at the end of the presentation for Q&A, so please place your questions into the chat box and they will be read aloud. Additionally, a recorded version of this webinar will be made available afterwards, so be on the lookout for that information. And with that, I will now turn it over to the presenters. Richard?
Thank you, ma'am. Can y'all hear me okay? This is Richard Kelly.
Yes, we can hear you loud and clear.
Great. I'm the Director of Next Generation Core Services, State and Federal GIS Advocacy at Motorola. That's a mouthful, but basically, after my 25 years or so in 911 GIS, I'm an advocate for understanding what the requirements are for 911 GIS data, the impacts of that data on both operations and budget and staffing concerns, as well as talk about the interoperability needs. I'm also a NSGIC's liaison from NENA, the National Emergency Number Association. So I try to provide, particularly at the annual conference in the fall and our winter conference later in the year, updates on what NENA is doing in the realm of GIS and interoperability for GIS data. I've got 9 years from government side, working at the county, regional, and state levels, and I've got nearly 20 on the private sector side. I've been everything from a 911 program manager and a tech to a system engineer to a software designer. I've worked with Jim Kringle, who's about to introduce himself, very well over a number of years. We've known each other, Jim, what, more than a decade now we've worked together. And I think with your experience, we cover a vast majority of site support throughout the country. And I'll turn it to Jim Kringle to introduce himself.
Thanks, Richard. My name's Jim Kringle. I'm a senior solution architect for NGCS with Motorola. And we'll get to defining NGCS in a bit for those of you that don't recognize the term. My role essentially is to understand not just the point that we're getting to, that we're designing towards for next generation 911, but also understand how we're going to migrate and build the products necessary to get from where we are today to where we need to be because of the phone system switching from our venerable circuit switched infrastructure of copper to packet switching, i.e. internet-based telephony becoming the standard. Like Richard, I have a number of years of experience. I worked at a couple of different local government organizations on different levels of government around Texas, and then moved to the private sector, where I've enjoyed the ability to interact and solve problems in a number of states, as Richard and I have worked around the country, helping people solve their GIS problems, and specifically their 911 GIS problems. So thank you.
Thanks, Jim. That's an important distinction, because as I was talking maybe before the call, what we're looking at, and as a reminder, I'm glad all of you could be here. Many of you Jim and I've spoken to through NSGIC or other venues. He and I've worked with, as he stated, with states on their GIS requirements, on standards, just basically consulting with where this is going to go. And our point today is, we call this a conversation because what we want to do for the first chunk of this is go over some content we think sets the table for our conversation on several key areas. If you got the meeting invite that had the outline of what we're going to cover, we'll cover each of those fairly briefly, and we'll leave time at the end for Q&A, as was noted already. But we wanted to make sure you understood this is not a a commercial presentation where we talk about our section of business and what our interests are. Rather, it's trying to impart some of our experience and expertise of what we've been running into for a number of years, what we continue to see, trends in the industry, and we think it's fairly helpful to go through this. From our perspective, the more people know from a common baseline of interests, ourselves and our colleagues at other companies, as well as other organizations, not just NSGIC, but APCO, NINA, and other groups. And we'll have a lot of acronyms today. Feel free to put in the chat box if you have any questions about acronyms or references, and we can try to pick up on those. But we want to make sure we talk about the practicality of using GIS data today in what's called the ECRF, the emergency call routing function. We want to bring the terms routable and dispatchable straight to you as far as what does that mean from the 911 perspective. If somebody says routable, that may mean something different, may mean CAD-based, computer-aided response. You know, if you're looking about that computer-aided dispatch system, that may be one thing, or it may be, some people may associate dispatchable with it. We want to make sure from the 911 next gen perspective, we try to imbue on you the understanding of routable versus dispatchable, why it's important to know what those are and the differences. We also need to talk about data. We get this all the time, Jim, I think. How good does my data have to be? What about, do I need to match to my legacy data before I can do anything? We'll talk about that. We're also getting into simplification of GIS data. Maybe we get away with more simple data, particularly boundary lines that have a lot of vertices that can be problematic. I mean, you'll have some boundary lines. Jim, what are some of the big ones? We've run into some boundaries for PSAPs that have more than 1,000 vertices.
Upwards of tens of thousands. I think the record for the data that we've helped people with was about 46,000 individual vertexes in a single polygon with 200 parts.
So think about that. And we have multi-part, we have very complex geometries. The expertise needed to build and manage this and to understand the impacts of this data within the software application being used, or processing time, or just getting good responses from queries, very important for people to understand that. We'll talk about 2D versus 3D. I've tried to provide to you the trend going towards 3D and vertical location and visualization. We'll talk about the reality of that a little bit, where we stand right now with regards to next gen. And then we'll talk about the supply chain considerations. We want to bring in what 911.gov, the folks at the federal level have been looking at, some really good reports, information. NSGIC's been made aware of this. I think it's going to be helpful. All of you, want to remind you what some of that content is, how long and how much. And that gets down to the bottom line. Whether you're a state, a county, a vendor, or a consultant, it's always going to be how long and how much. How long does it take to build what I have to have, and how much is it going to cost? Not just in dollars and cents, but also in resources. And again, what we want to make sure is what we're going over today, it's based on work being done by us, some experience in NINA, 911.gov, and others. So we'll have a lot of things coming along. Jim, I'll go through and talk about some of this, the foundational understanding. For what Jim and I are going to talk about on the data side, it's important to understand several references. We hear the term tabular routing versus geospatial routing versus location-based routing. We want to make sure when we talk about tabular routing, that euphemistically refers to how we have always routed a call from the telephone line system to the call handling position at a particular, and you'll hear PSAP or ECC. PSAP stands for Public Safety Answering Point. ECC stands for Emergency Communication Center. They both can reference the same thing. Sometimes they're used differently. NINA uses PSAP a lot more often, and APCO uses ECC a lot more often in each of their standards. So tabular routing is what we've been using up till today, and still are in most places, as we transition to the right of that, geospatial routing, where again, we're using an ECRF, an emergency call routing function with a piece of software that has onboard GIS data to help determine which 911 center, PSAP or ECC, the call needs to go to, based on its location compared to that GIS data. Now we'll talk about selective router databases, the SRDBs. That goes hand in hand with tabular routing. So think on the left side is what the old systems we're using. We use tabular database, which are usually subscriber databases, and the selective routers are run by folks like AT&T and others. that have that tabular database in there. They route. Jim will be able to add a little more content. We go through a couple diagrams. But on the right is the next gen world where we're using GIS data, not a static, telephone number assigned to a house or to a cell phone that comes through a tower and sector. Rather, the location that's delivered allows the ECRF to look at the GIS data with that location, be it a X, Y, and Z for a wireless type call, which the term in next gen is geodetic, or it's a civic type address, what we used to call a landline, 105 Main or something like that.
And
Location
Richard,
based. Yeah.
I'd like to
Let
add
me
just a little bit of
let me throw
color.
this one word out that
Sure.
you kind of. The location based routing we're going to talk about in a second is really on the front end when the location is available, not necessarily geospatial routing, but the location facilitates the service provider determining where the call needs to go to ahead of the curve. We won't get into location based routing. We did a presentation for NSGIC on that, and Amy, I think that's available online with NSGIC, but that's something we did, I think, at the last one. So Jim, take a pause here. What have you got on this slide before we move on?
Yeah, I just wanted to add a little bit of context and color to your thorough explanation. And that is from a Motorola standpoint. We often see these terms defined negatively as tabular routing is not geospatial routing. Geospatial routing is not tabular routing. And so the definitions, as you move through the industry, these definitions are kind of vague. They're applied in different ways by different service providers. And incidentally, location-based routing, as Richard said, this is about having the location at the time of the call to get there. Well, geospatial routing
Maybe it's me.
is a form of location-based routing. But in the industry, the way the terms have been adopted, they're not always intuitive. So someone looking at this for the first time would imagine that location-based routing means routing with a location, and geospatial routing means routing with a geospatial location. So I just wanted to kind of amplify here Richard's words to say, be careful with these terms because they're not always used exactly the same way. And from a Motorola perspective,
I think I got dropped for a section. Sorry.
Oh, thank you, Richard. No problem. They're not always mutually exclusive. One does not have to completely stop tabular-based routing in order to enable geospatial-based routing, and vice versa. They've been drawn as opposites, but we see them as a continuum where routing can transition from traditional existing, the standard by which things are done today, transition that into routing based on the GIS data and location.
Right. I appreciate that, Jim. And again, we've talked about location-based before, so we won't get into that too much today. But I wanted to show, Jim and I wanted to show a simple comparison. This
Richard, I don't see your screen anymore. Sorry.
Oh, let me make sure we're up and showing. Yeah, like I said, when I got dropped, I think let me see if I can get this. Thank you, Jim. That's what I need you to do. Tell me if you've got the screen now.
Yes, sir.
Okay, let's go back to this. So what we'll do, and we just finished that slide there, we're going to go to this simplistic diagram. So we compare and contrast before and after using GIS data for routing. On the left side, we've got these little numbered here. If you have a wireless or VoIP call with a pseudo-ANI, basically you're going to have what would you call it? Interim gem or a temporary identifier associated with that incoming call to the service provider, like an AT&T or Verizon or someone coming in. Or you have a landline call, the wireline call with the automatic number identification, which is ANI. So that pseudo-ANI or the regular ANI, that's going to be introduced to the selective router, which Jim's touched on. That selective router is the telephone company database system. It'll take that and say, all right, my database says what? And that's the SRDB, the selective router database. All the telephone numbers and all the cell towers and sectors, all that's in a database, which either the PNE or the ANI can hit and deliver the appropriate information to the select router, say, I need to go to this PSAP or ECC. That's really what gets the call and the telephone number there. Notice there's no location going there. That's just the number, telephone number, the PNE or the ANI, that automatic number identification. Once it gets to the PSAP, there's a process called a DIP. For every provider, if this in the old world we've been doing up till today is, I've got a telephone number. I'm going to check with another database called my ALI, the automatic location information database, and say, in next gen it's going to be LDB, so we'll carry it through to a degree. But I'm going to check, see that telephone number, what's the location for it? And if I've got a landline location, like wireline, it'll have it. However, if it's going to come in from a cell phone or something and it's moving, we have what's called a mobile positioning center and a VoIP positioning center, which again corresponds to the wireless or the VoIP calls. This will be a database that'll be able to refine that location via an XY through their proprietary technology. So that telephone number that's coming in from the PSAP, it's going to be dipped to the location database. And if it's not a landline, it's going to have to go out to these special service providers that say, you got a moving device. Let me give you some coordinates for it. That's what we've been depending on for decades. Since, Jim, I think the mid to late 90s when wireless really came into play. So nearly 30 years of this. In the future, however, for a whole bunch of reasons we won't get into today, the next generation core services offering allows us in the industry, and this is going to affect every single one of you, your families, your friends, everybody you know, without anyone knowing it to a large degree in the United States. We're going to switch all that technology out. We're going to switch out the selective router databases from the telcos. We're going to switch out the copper line networks we depended upon. We're going to change out the concept of independent hardened centers that can only be entered through this copper line underground. We're going to change it all out to a private internet type solution called the Emergency Services IP Network, the EZINet, and we're going to have that incoming call location. We'll still have it from the carriers, but that call location will either have a location specifically or location by reference. And location by reference means, so if I get location value, I know it's at 105 Main or it's at X and Y, whatever the X and Y is. But if it's by reference, it says, go to this database or this capability, and I'll tell you what the physical location is or the coordinates are. So when that information comes in, we're not going to have the selective router database, the SRDB anymore. We saw in the previous file. This is going to go away and change a little bit. We're going to use GIS data to determine. So that location comes in on the left side in a format called PIDFlow. That PIDFlow replaces our ALI format that we have coming in. And when it does on that GIS data, same process, now we get a location or location by reference, which still gives us a location. And it says, all right, I'm going to give you the latitude, longitude, which is a geodetic, or I'm going to get you the landline, which is now called civic. And I'm going to go to this thing called the Emergency Services Routing Proxy. What that basically is typically a non-telco selective router, but it's digital. So think of it as an IP-based selective router, right? That internet proxy or protocol capability allows us to put a lot of digital information that just simply can't be carried on the old copper lines. That new digital information gives us a lot more information than a simple name, address, and 3 responders. It can give us everything from HIPAA records to law enforcement. Everything can be carried and associated to a specific number. Or in this case, a caller record that's going to come in from PIDFlow. You'll have the caller, you'll have some location information, and that ECRF with the GIS data will take that location, compare it to GIS data, and determine which center to send the voice and location to. There's no dip here. It's automatically going to send those recommendations there along with other things. So GIS data drives call routing, response determination for the emergency services routing proxy. Real important to understand, voice and location do not get to the PSAP unless this ECRF does its job. Or if it's not available or it's out of area, the ESRP, the digital router, the selective router replacement, the ESRP, it will determine through default or pre-programmed instructions what to do if the ECRF can't find the location. It's out of area. We've had situations, Jim, where someone may be vacationing in Italy. They call and it goes back to their home location address in Georgia. And now suddenly we've got a foreign call coming in, or even between states, and that gets to be a challenge. Any comments on these three slides, Jim?
No, just to reiterate, what you said there. This icon down there at the bottom, the ECRF, this is where all of the decisions that have been made and understanding and knowledge that lives in our GIS, this is where it's put to work in the next generation 911 system.
And with that in mind, let's talk about routable versus dispatchable. We got a few slides here to just basically highlight it, but in short, and I've got it in blue here, when we talk about dispatchable location, the FCC has defined, you'll see that the FCC has really been a driver on NextGen in a lot of ways outside of NENA's standards. Starting back in 2014, there was a roadmap set up by the FCC, NENA, APCO, and the four largest service providers, Verizon, T-Mobile, AT&T, and Dish Wireless. And they said, we need to get this this IP network up and running so we can deliver more information, more content, pictures, video, not just that, but also all kinds of other location information. But we need to have that location improved. So they provided guidelines for how to improve the X and Y, the coordinates. And when they provide this, said what we need is a better location that's not just X and Y. We need to add a Z to it. Or we need to have subaddressing that tells us what floor a caller's in, because they wanted to take the vertical reference into account. So you'll see when we talk about dispatchable location, that's going to be enough information for a responder to know exactly where that caller is. Okay. And the vertical location, the Z, is part of that dispatchable location. So whether it's a Z value or whether it's a civic location of building and floor and suite, whatever it is, that FCC defined, I've got it in yellow there, street address of a caller plus additional information such as floor level to identify the 911 caller's location. From your side, if you're a county or a state or other organization, we're going to have to provide the framework, that mapping data to which that's going to be visualized and associated. So we're going to go into a new world where we need more granularity of the information than our two-dimensional maps we're using today, in addition to the routing issues. So remember, with today, when we do routing of calls, we really do it in a 2D world. There may be a difference. If I have a call coming from the 100th floor of a skyscraper, there may be a different fire responder than the one that can only go up the first 10 floors. So we want to be able to accommodate that when we have a vertical factor, be it a Z value or be it the floor reference. And there's software right now that'll help refine that. Let's say I get a floor, it may be able to convert that to a relative height. Or if I have a relative height, your software used in 911 may be able to convert that to a floor, cross-reference that with a degree of accuracy. So that's important. And the FCC at this last spec, when we get into some of this, I want to remind you guys that the FCC stipulated there needs to be an accuracy requirement of 3 meters plus or minus, no more, which is roughly the height of a floor for that vertical location. So this is all the FCC mandate. We talk about routable. We've got a couple points here on what routable means, preparing the MSAG for NGCS routing and preparing the PSAP boundaries. Jim, I don't know if you have any comments on routability, which is what we were just kind of focusing on, how to route the call.
Yeah, and the distinction here is very important to all of us on the call as the thinkers and doers. For you are making sure that your states, your organizations are getting the work done. And this distinction between what is dispatchable versus what is routable really gets to the numbers, the amount of effort involved, and the goals for the particular phases of a project. So as Richard stated, dispatchable means we have the best information we can to convey to another person exactly where that incident is happening, not just at 122 Main Street, but 122 Main Street on the 5th floor in Suite 101. This is the kind of information that we use for, appropriately enough, dispatch. This is how we dispatch someone to that location. Now, when we take a step back and we think about NGCS, how do we enable our 911 systems to grow into the next generation 911? We can think more about our first step on this process is getting to being routable. Whether that call is coming from the 5th floor or ground level, doesn't matter when you're trying to get the call to the appropriate PSAP. It matters for response. So
Hey, Jim,
yeah.
Jim, can you also provide context for the folks in the audience that are GIS data builders or providers? You do very well at discussing that we're baking in instructions for routing.
Mhm.
Can you talk about that on if we're building address points or road center lines, what the importance is? Because there could be implications for whether it's the NAD, that database that's up and
Mhm.
running, or local data or commercial data that's being used, understanding the decisions that are baked into the data. Could you talk about that for a bit?
Absolutely, absolutely. And so when we talk about ensuring that data is routable, that's the first step on our journey. That means that we're able to, with the data, the GIS data that we're providing the system, that are able to deliver the call to the appropriate agency so that they can respond. And their response is when dispatchable location becomes important, that granularity. And to Richard's point, the granularity of our understanding of the GIS data is that every time someone adds a new address point and they decide where to place that address point on the map, they are
Exactly.
explicitly defining for someone, where does this abstraction of a civic address,
Yeah.
what does that mean specifically? And the more specific we can be, the better our dispatchable understanding is. Our routable understanding gets us in the right ballpark. A majority of the rural area of the United States can be routed simply by understanding the county that the
Yep.
call is coming from.
And
So
what I wanted to
mhm,
focus on with you here is routable is the priority.
mhm,
Dispatchable is not the nice to have, but it's the second consideration. We want to make sure we get the call, the voice, the caller to the correct center, to a human. That
mhm,
routable is essential. And that's going to have a degree of data requirement different from getting the granularity of someone who may be in the middle of a large conference room versus in a closet
mhm.
or in a crawl space.
Exactly. Exactly. So routable is our first goal. Routable means that with the next generation system, our GIS data is able to perform call routing as well as the existing traditional database system
Yep. Or
is
better.
today. So that gets us to routable. Then, as you pointed out, dispatchable is our next goal. So often we see that this is an inefficiency in long range planning for agencies. They try to get everything to dispatchable first
That's
before they start entering into the next gen world.
and that's
They
common
feel
around
like
the
they're
country.
behind.
That's why we want to bring it to your attention that if you're representative of a state or counties within a state, we've got to make sure, think about it. If you've got 100 or 150 or 200 counties and your job as a state coordinator is to shepherd them along, the first thing we want to do is make sure you get your ESINet installed, that you have all the required acronym alphabet soup of applications, border control functions, BCA, F's for security and your ESRPs and all these other things, but that the GIS data is suitable. And you can even use an MSAG for this with the ESN associated with each of those MSAG records. You need to make sure that you can route those calls. As good or better is what NINA, for example, has always built its standards as they change and improve 911 in the United States and Canada and other places. We want to make sure that we account for as good or better support and capability. And that's why the routable gets us to where we need to go. And dispatchable is what we're aspiring to. And that's where something like a computer aided dispatch system, a CAD system, or a higher end ability to look at data in a 3D perspective may help those call takers deal with that. And Gemma, while we're going through this, let me go to the practical ECRF days needs today, because I think that's going to tie into you continuing your discussion when we talk about the practicality of that data. Can you touch on these points, for example?
Absolutely. Absolutely. So we just kind of hit on the idea of this ideal of what's being asked for dispatchable location for civic addresses. Let's put this into perspective a little bit. Many of you are familiar with the adage of the 80-20 rule. Well, it's actually more like 90-10 in most places. 90% of the calls that happen to get to our communication centers, our PSAPs, are wireless calls with geodetic locations. So to handle 90% of the traffic in a next-gen system, 911 calls, all we need are suitable service polygons. Those polygons, initially, the requirement is just for the PSAP. Let's get that call routed to the right place. If we get the call routed to the right place, response kicks in from there. So the simple layer of a PSAP layer, and remember, a majority of the country can be routed on county. So a PSAP polygon is actually a fairly simple quantity for a lot of jurisdictions. And that PSAP polygon layer is the most important GIS layer, the most important GIS information that you can put towards the goal of NGCS. And we harp on that, we bring that up because we often see the polygon layers coming in secondary, being almost an afterthought. The majority of the work on the outset of a 911 project, 911 GIS project, is jumping in and working on civic locations. And the civic locations already are a vast minority of the calls. And so to route 10% of the calls, we're seeing 90% of the effort go into those. And to bring the ECRF online, to make your jurisdiction ready for the transitioning next generation 911 world, the most important thing you can have is the PSAP boundary layer, followed by your responder boundary layers. And those are relatively simple to create. Now, nothing in the GIS is ever simple. It's never finished. There's always more that can be done. Identifying who owns what and resolving issues and boundaries, but it is a solvable problem. And it is a problem that bringing yourself to the ability to start the path of next generation 911 starts with a PSAP polygon. And those 10% of civic calls that are happening today, those in our system, we don't draw a hard distinction between the operation of yesterday and the operation of tomorrow. So we don't have to throw away old knowledge in order to bring new capabilities. So practically, the ECRF only requires to invoke an ECRF only requires PSAP polygons and an MSAG that is already existent.
Here is something I'd put out there too, and I've said this before. When you build a road, you're a civil engineer, you build a road or a bridge or whatever, that's pretty much there forever, at least for your lifespan. It may be improved or replaced or expanded on, but it's always there. Roads, railroads, most of the time, that type of infrastructure doesn't change. Same with plumbing, right? You got water lines, you got defined areas where it goes in, it may be expanded on, replaced, or fixed, but once it's in, it's in. I would put forward, and Jim and I have talked about this, that the data we're building for 911 is forever data. When you put those roads in there, when you put those address points, those polygons, yes, they will change, but basically the databases we're building for 911 and next gen are forever. They are a living, growing thing. Many times we've seen where people say, well, I just need to check all my data and rebuild it all, or cast considerations towards maybe I'd start over. That's not the way this is going to go. We're custodians at any given time for the data. It's multi-generational, as it were, for people with careers. As we have turnover, people are coming in and being custodians for that data and carrying on the traditions and the standards that were set before they even got on into that role in most cases. So baking the decisions in, data is always changing. Data changes whether you know it or not. Sometimes without you trying. Right? Somebody can, Jim. We've had examples where people have accidentally selected an entire data set, shifted 100 feet without even knowing it. We have to be smarter than the data by baking into our data the decision making and designing into our applications a way to catch those things which human error can introduce. And this takes us to the next thing, Jim, you can talk about. How good is good? Good, and good's relative. And I would say, for your comments, Jim, that we need to focus on three aspects: completeness, which I think is the most important thing, making sure you have the required layers versus recommended versus optional, as well as the attributes. Timeliness, after completeness, we need it complete. Jim was talking about the polygons. We have to have wall-to-wall data at a basic level, but it has to be something that reflects what's accurate today, that as far as the time we're at. If we need to make a change, we have to be aware, we need to be timely in getting those changes. And then there's accuracy. Jim and I were talking about the very large vertice polygons. We've had people saying, well, to make it process, let's run Esri's simplification tool on it, or what are proprietary tools. We got to be careful. Jim, I know you know this, and some of you who are on some of the work groups at standards organizations, NENA or APCO, when people say accuracy, again, that means different things to different people. So Jim, can you take just a couple minutes? I want to make sure we're starting to run along on time. Completeness, timeless, and accuracy, particularly as we talk about people who have the custodial role of the data, and how that process needs to be documented. So you have institutional continuity. We have continuity of how data is built and managed.
Exactly. I think you laid it out very well. What we need: completeness. We need the data that we need. We need the data that we're going to use. So as Richard said, there are standards out there that define what's required, what's recommended, what's optional. But those standards often are interpreted by our implementations. And depending on who does your implementation, what roles we have, those are not the same answers for everyone. So it's important to understand what your goal is and define your simple, achievable goals for each phase of your transition. What do I need? Not just I need this end state vision, but what do I need to accomplish what I need to get done today?
And
Have
Jim,
that complete data.
You've seen this at sites, right? You work directly, whether they're in Florida or Maryland or Utah or wherever we are in the country. You've seen instances where we've had to work with folks who are custodians in some cases and not in others. They're corralling, herding the cats, right? Where some counties may have the capability to do it, build and manage data on their own, and they have to fit into a larger puzzle piece of an entire state or a region. We see that, and wouldn't you say the documentation of that process in every time we get involved, if they, and I'm thinking of a particular site in Florida you've been working on, if you document the process, that gives you some guardrails, particularly as staff turns over or program directions change. You've documented what you do and why from the GIS side. Is that correct?
Absolutely. Absolutely. Because without that, you bring up a point that could be an entire presentation on its
I
own.
know. We got a
Uh,
lot of good nuggets in here.
Keeping continuity as we move forward.
And I'll throw this one up right now. I want you to keep going. We have simple versus complex. I debated whether to put KISS in there. I look at KISS as keep it simple, sir. You guys can change the S to whatever you want, but not derogatory at all. Jim, what we're talking about, and I know we're talking about the same subject, but I want to bring in different facets of the subject. The keeping the data simple. You've already touched on
Mhm.
it. We can start routing with MSAG to test the network, kind of like a leak test to make sure everything works in the next gen world, starting with that traditional data. Then as you build data, basic data first, as we said before, it's better to have that complete data. And wouldn't you agree that we're seeing this now? We're going to save 3D for a minute. Data will get more complex over time. I
Mhm.
mean, this is as simple as I can make it. If you go with a basic road centerline layer for the 10% or less of your calls that are civic, they're a regular address, not coordinates. Um, Over time, those roads will get more complex for other needs, like computer aided dispatch. You may have speed limits and directions and other things. So it's not like, and I want to focus on what Jim said. People leap ahead and say, "Oh, I'm going to use a standard. I'm going to fill out everything." You can set the data up to be augmented and added to later. But what we got to focus on, and this is a theme throughout today, what are the basics we need at a local and a state level? We need to make sure the data has all the basics. It's up to date. It's correct. It's as good as we can make it for the basics.
Mhm.
And then we'll add other things as needed as we go along. And those boundary lines, Jim, how do you see the boundary lines between cities and counties? Uh, uh, how do you see the alignment issues? For me, the biggest thing, and I've talked about this before here, I'm worried about the alignment between cities and county lines. So we have a commonality between adjacent jurisdictions.
Mhm. Absolutely. Boundary issues within organizations, within GIS, a single GIS, are difficult enough for folks to identify and resolve because they can get very, very delicate. What does this boundary mean? It's not just simply there's a gap here, but is this intentional? Is this gap intentional? Is this gap created because of the difference in how the features were created? Or is this gap here because of some legislated reason? You know, that it's not simply just picking up a GIS feature and moving points oftentimes. And then when we go outside the organization and we start interfacing with our neighbors, it becomes very important and it becomes even more delicate. And one of the things that we often see is projects and processes will get bogged down working off of working off of the idea that they are identifying a legal boundary, identifying the county boundary, the
Yes.
city boundary, instead of taking a rightful step back and saying, I am not legislated to define this city's boundary.
Right.
I am here to define what the agreement is between our organizations for how to route calls. And that necessarily corresponds to and may follow closely the city or county boundary,
And I
but
will
that
add to
doesn't
this,
mean that
Jim.
it has to.
Right. Right. I would add to this that it's not the goal, role, or even the ability in most cases for a vendor, the software developer or the consulting firm to make that determination. It's Jim, you and I have dealt with this with almost every jurisdiction. Those jurisdictions have to define those boundary lines and work with their neighbors. And I put this forward for years at NSGIC. Whether we're talking folks from NASNA or ERISA or wherever. The challenge of our time to make sure we have wall-to-wall interoperability and we don't have figuratively gaps in our solution coverage is to make sure that we have consistent, coincident county and state lines for the purposes of next generation 911 call routing and responder determination. Because every state boundary, and I would put forward further, every county within that state boundary are going to serve as the cookie cutters for the other data that's built, address points, road center lines, routing polygons, all of that, the responder polygons, all of that fits within the construct of a local county. And then that county needs to fit within the state, and those coincident lines between the counties facilitate, interoperability discussions and data corrections as necessary. And I still see that as the challenge of our day until we get these systems up and online. And we're still a ways from getting a comprehensive and a consistent approach to that, Jim. And I'm going to move on as we go through.
Agreed.
And we can talk a little bit about how 3D, and I want to make sure we'll have some questions there. I'm going to try to get through the last few quickly so we have a little time. The next generation core services, again, that's NGCS, 2D or 3D. There's been a lot of buzz about going 3D. And I wanted to make some simple observations, Jim and I both, on 3D. And again, notice at the top, when we're operationalizing Z, our concern is how's that going to affect the routability or the dispatch dispatchable information. So, excuse me, the routability. This is a simple example where we may have calls that come in. There's an accident on the bridge. And in this case, the blue dots may represent altitude at around sea level, and the red dots could show altitude at around the bridge level. Now, you can take an incoming Z value, you can color code your caller location just like this. And you may have multiple calls, as this example is showing. But we have to ask ourselves, this goes back to what we already said, baking in routing and responder determinations into the data, where should the call go? If we don't use a vertical measurement, in this case like a Z value, we won't know whether or not that call coming in from a blue dot needs to go to Coast Guard or Park Service or Fish and Game, or if that needs to go to the city if it's the red dot. So while this represents a simplistic display, think about how we're trying to show you the visualization within the next gen system that says, okay, if I've got a Z value above sea level, that's probably going to be dealing with city. If it's at sea level, because the rest of the city is not, then that's probably going to be something on the naval side. Maybe the sheriff's office got a patrol on the water. Okay, so asking where should the call go and who should respond, that's what Z-axis brings new to the equation to switch that up a bit. And with a building, it's even more interesting because when we talk about, again, routing's pretty much going to be the same location. A PSAP is going to handle a call whether it's on the ground floor or the third floor, as in this example. But the dispatchability, that the information of where that caller is that helps the responders get to where they need to go. Remember that plus or minus 3 meters Nina threw at us via FCC? The NGCS system, are we going to have to take that vertical location and change the responder? We use the fire department as an example based on that. Are we going to use a third-party application? And there are many, we won't have to go through those, that says, oh, I have other information about the building or other information about this particular phone number or this caller that will affect who my responder should be. So is that going to be, our considerations now are in the community, do we need to bake that in, that decision for who the responder should be based on a height? Do we need to bake that into the software through a third party? Or do we need to just let the PSAP, the public safety answer points, or the emergency communication centers determine that? Because if I get a call that's going to be somewhere within this circle, plus or minus, we got a circle at the top and the bottom, and I can relatively accurately say it's in the middle of this cylinder, maybe it's in that room. What's my obligation to derive that, to to interpolate or interpret that with software, and then tell the call taker, we think this person's in that room? Who has the onus to say, I have to have GIS data that represents this, and tell them where that caller may be located within a structure? That's an order of magnitude of complexity on the GIS data to use. And again, I'm more of a two-dimensional person for now versus 3D, but we do have jurisdictions that are constructing three-dimensional rooms and are taking, we saw some of these presentations, I think at the NINA conference, where you would have, for example, there's a site in Florida, they would take incoming digital floor plans and basically take that and convert them to three-dimensional constructs with an average ceiling height where the walls would be constructed. So we're now seeing examples, I didn't put them in here, where we're having three-dimensional rooms based off of two-dimensional diagrams. It comes down to which is best? What do you want to do operationally? How do you want to train? Is that data sustainable? And for us, it comes down to, what do we tell people? Okay, I like 3D. I know I need for my emergency call routing, I have to have roads, I have to have polygons for responders, I have to have the PSAP or ECC layer. What about this 3D stuff? This is pretty cool. We have sites, I know several that are working on their address points at the bottom line, are really focusing on that sub-addressing. Remember we talked about dispatchability, not routable, dispatchability, where we have the granularity, that location. If it comes in, do we want to match it up? Do we want to have the location to be able to click on a data set in my CAD system or my mapped alley that shows that granularity? So address points with sub-addressing is something that people are tackling now. I will tell you that the address points, the site structure address points in the data model as a required layer helps. Don't forget, we talked about this on the NINA side, that three-dimensional room constructs are also probably going to be added in the next version of the data model, version 3. I know I and Brandon Abley and many others are working on it from the 3D side. We will have a requirement for 3D data in such that you have this building construct here on the right, so that people who want to pursue that can secure funding or basically pursue that legislatively through their local legislation or their funding mechanisms. But for us, what we wind up telling people is, okay, if you're starting with address points and sub-address information, then maybe you want sub-address those address points, make sure there's an elevation attribute associated to it, so that when we think about this, the paradigm shift from 2D to 3D, are we able to visually see how 3D maps are visualized and manipulated by an editor? How do we build and manage 3D maps? That's what you're going to need to be able to understand where that vertical geometry comes in, that middle value. And then 2D building footprints, that's easy. I showed you that before. But 3D building polygons, we've talked how people are already moving towards that. And then there's interior spaces. There's been a suggestion that we need to have heating and air conditioning ducts, wall spaces, attic crawls, balconies on apartments. We need to have even more data. I think, Jim, we had one advocate was saying we need to have a centimeter or less accuracy on internal room arrangements, which to me is off the charts as far as complexity and cost. But what we're seeing is, for the 3D side, a focus on schools, churches, and other mass gathering areas where the likelihood is higher of having a medical emergency or something else where you may need that. Airport's another great example where that granularity is helpful. Okay, Jim, did you have any comments on that before I go to the last bit?
No, sir.
Let's go through the GIS supply chain. And I did want to bring this up. Working with 911.gov, I know NSGIC works with 911.gov. They did a good job on bringing out the supply chain considerations, a series of reports where we're talking about educating local governments as a parameter of necessity. That's the first one in yellow. Basically having a plan to build or acquire GIS data is an important area of work. And then knowing the core requirements for the next generation core services. These three topics are discussed in the 4 reports I've got listed here. I was made aware by 911.gov of these reports. I've gone through them. They're pretty meaty, but there's also some overlap between them. We want to make sure that and I'll get to that in the next one here, but there are numerous standards in NINA, these 4 standards from NINA, the data model, stewardship, provisioning GIS data, and the I3 architecture. Those 4 support what 911.gov is outlining when we talk about educating, building, and knowing the core. We get a lot of the build, buy, or both. Here's the interesting thing in the industry. The GIS software and services vendors, we have a vested interest in making sure the folks understand they're informed consumers of what they need. And that goes back to the previous slide of educating them, making sure they know how to build or acquire, and they know the core requirements of those 4 standards. But what we recommend for whether it's a county or state government, to ask some basic questions. I've got a list here that Jim and I have talked about. When you ask a provider, a service or application provider, solution provider, what's your approach to quality control? What's your responsibilities versus ours or anybody else in our implementation project? What about third-party access? How secure is that? Do they need that? what's the total cost of doing this? How much do I need to spend on a program so we don't surprise people as costs start
Mhm.
piling up as more and more things are added? Workflow creation, industry boards, there's a lot of consideration that goes forward. And again, 911.gov went through this, these 4 reports: current status of 911 GIS systems technologies, GIS technology current status of required entities, GIS technologies partner agencies and organizations, and GIS technology the national strategy. These 4 reports, which NSGIC was a participant in, and they're listed in these documents. Bear in mind, they go back and cover these 3 items we talked about: educating locals, making sure the people who are part of the process, the stakeholders, are educated, and dealing with building requiring and the core data. That's all part of it. And then we get to how long, how much. That's relative. Our concerns now are going to be budgeting for GIS staff time, recruiting or training, system data recovery planning. That's a big one. Who's going to be your 2 a.m. GIS expert, and data updating service? We have people now that are, they lose staff. They want a qualified service provider to do the work for them, maybe. And that's an overtime consideration for corrections and maintenance, where some people don't necessarily want to be in that business. So do we need to start talking about what's the bare minimum a GIS service provider needs to provide data for? 24-hour GIS help desk, is that going to be necessity? I mean, these are the things we think about. And Jim, I would ask you on these last few slides as we run out the clock,
Mhm.
is there anything you'd like to add to what we're going over and trying to impart today on this presentation?
Absolutely. Thanks, Richard. I think we hit on the theme early in the presentation, and that is that as we move to next gen, all of this has to boil down to, as we transition to a next generation 911, which is coming. It is something that we are all going to have to do sooner or later. And for most, it should be sooner. We need to prepare for this now. As we move to that, we have to ask ourselves clearly what our goals are. The difference between building and maintaining data for routing versus dispatch may involve an order of magnitude or 3 in difference of cost and effort for your organizations. Things like the Z-axis, like Richard was pointing out earlier, simple versus complex data. How much complexity can we build on this? And the people who are defining standards are looking ahead 10 to 15 years, defining what we think
Yeah.
this should look like. They're essentially writing a sci-fi movie. What do we think this should look like in the future?
And
And
Jim,
too many
Jim,
times that's being interpreted as these are our requirements of what we have to do today.
and Jim, you've seen
Please.
where keep data evergreen, the states, when they take an active hand in us, either whether it's setting an approved slate of vendors that can provide certain goods and services, or whether they mandate a certain set of criteria for a data model for the state. We've seen these in play in many states around the United States. That's gratifying that the states
Mhm.
are taking. I think they're the appropriate level to provide that overarching consistency guidance. The states that do that find a lot more success, and I would say a lot faster ability to implement, or at least get people on the same page to build towards this throughout their state. And states are starting to see that more and more. We're seeing that in statewide RFPs, and we've had several states just in the last year or two that have gotten on board with that.
Mhm.
And that's good. And then to see 911.gov, the federal 911 office, provide these overarching supporting documentation of what the industry is doing, that helps people pursue resources or legislation that would support their local and state level work. Anyway,
Perfect.
we got through that. I know we're at time, but Jim and I are glad to answer any questions if we can on this. You can put them in the chat box. We're glad to respond to you. What I would say is that from my perspective, and I'm speaking on behalf of Motorola at this moment with Jim, we're glad to provide the context for what we're seeing, and we're hoping that several of these observations and recommendations help frame what we're seeing as trends and our recommendations for consistency in the industry. Jim, would you agree?
Absolutely. Amy, we've used up our allotted time. Would it be possible for us to respond? If anyone wants to hold over later, we may, but would it be possible for us to respond to these? There's been a number of good questions. Respond to those over email if we don't get to them now.
Yeah, there are 2 questions in the chat box. If folks would like to stay and do like a quick session for the 2 questions, and then anyone else, please feel free to send the questions directly to me to be distributed to Jim and Richard. But I will go ahead and ask real quick. Maybe we can just do like a quick session.
Yeah, go ahead.
Matt asked, I struggle. Oh, sorry. Yeah, Matt asked, I struggle with need for PSAPs/ECCs to visualize dispatchable locations. Isn't this detailed level of granularity needed by the responders, not those who answer the phones and dispatch responders, excuse me. Can you argue why it's important for PSAPs to see mapped where room 200 is versus room 300? Doesn't the spatial detail visualization belong in the field in the responders' hands?
Well, that's a great point. And Jim, you may have some addition to add to this, but it really varies by jurisdiction. We have some jurisdictions where the person manning the radio at the center, they are providing that additional guidance that, let's say, a patrol officer may not have, or an EMS responder. In many cases, they're trying to do that. And there are jurisdictions that don't have a lot of resources in the field, in the units, that can help provide that degree of granular location information. So it'll come over the radio or some other mechanism. But there are a number of folks that have a system design where that information is supplied to responders in the field in real time. So it just depends on the jurisdiction. But there is a large, Jim, I don't know about you, but I think there's a very large amount of people who are going to get that information from the comm center over the radio as they're working the situation. Would you agree?
Absolutely. I agree completely. It belongs in both hands. One of the common threads, and throughout the country, 911 and response is a local issue. So it's done many different ways, but commonly you will see that in a dispatch center, in an ECC, in a PSAP, the person who is sharing that information to the responder, that responder is responsible for resolving that situation. But the person who's managing them, who's talking to them over the radio, who's dispatching them, they are responsible for that person. So having them with that knowledge and understanding of what is around the person they've dispatched is an important link. So I would argue that it's very important for both sides of the equation to see that. And we see applications in the future being very specific and bringing that information right down to the responder. Great question.
Does that help? That's a great response, Jim. Yeah, I think it both.
And then I'll take one more question. It was from Jeremy. When talking about the dispatchable location, where should the detailed location information, side note, floor, room, desk, live? Should that be in the GIS, or should it be maintained in the ALI by the OSP in their own LIS?
Another good question, and we're probably going to say both, because what you're going to have coming in, this is part of next gen. If that location information, that granularity of let's just stick with a floor. If I know the location delivery is going to include a floor with it, then I need to be able to understand what that floor value has as far as an impact on the responder in my next generation core service system, specifically the ECRF and what it recommends for a responder to the rest of the system. But likewise, if you know how 911 call dispatch systems work, mapped alley, if I have an alley record that has an X and Y and it comes in, I need to be able to plot it on my map or associate that XY with an address point. There is a conversion process necessary to say, okay, I've got an X and Y I can place on the map, but I've got a civic location like 105 Main. I need to geocode that either to a point or a line, so that if we're going to say, let's say we have an apartment complex with 10 units, and I want to have, let's say I am getting that unit ID into my alley information for my call handling equipment, and I have 10 apartment units, and that alley includes a unit ID, then I would need to put a unit ID on each of my apartment units that would match that incoming location. So my map display or CAD would light up the appropriate apartment unit. So it's very much a right and left hand in concert, understanding what's coming in for the location information to what degree of granularity, and to be able to match it up with your GIS data, you would have to attribute data on your map display or your CAD system to marry those two up to get a better ID locally. And just to do searches. You could do searches and lookups in your mapped alley or your emergency notification system or your CAD or whatever the application is. Even the MDTs, the mobile data terminals and responders, having that granular information would be helpful for lookups. Does that make sense? Okay, Jim, you agree?
Absolutely. And I think there's one little side offshoot here to remind everyone who's stuck with us. And that is, you as the GIS data provider, you have the power, because there's something in NextGen called a location validation function. And if a service provider says they're putting in telephone at 122 Main Street, if your GIS data, the decisions within that data say that you don't recognize 122 Main Street, you recognize 122 Main Street, Suite A, B, and C, you can, with the power of your GIS data, let them know that their location is not good enough through this process. So you are defining how well location can be and must be provided by the service providers during a 911 call. Great question.
Well,
And so we both answers got to be both.
Well, thank you. Thank you, Richard and Jim, for this wonderful presentation and staying on late to answer questions. Unfortunately, that's all the time we have to take for questions. Anyone else who wasn't able to get to, I will be sure to pass those questions along to Richard and Jim directly. Any last comments from the presenters?
We appreciate you giving us the opportunity to provide this information. We'll look forward to continue to support the work that NSGIC does. And don't forget, we'll have a presentation on the NENA activity and standards at the upcoming annual conference.
Well, thank you to the audience who were able to stay with us. And thank you again, Richard and Jim, for giving this wonderful presentation. And I hope all of you have a wonderful afternoon. Thank you again.
Thank you.
Thank you.